Hello, everyone. Good evening and good afternoon and good morning, depending on the time from where you are virtually connecting to this session. So, this topic is learn to build a scalable knowledge graph for 360-degree personalization of customers. And it is something which is very close to my heart, and I have developed expertise in building the knowledge graph for this personalization for like millions of customers and different industries. And that way, what I would be sharing would be like a kind of a professional to professional talk where whatever I've learned over the time in my journey to all of you. So just a brief introduction about myself. I'm a group manager at Intuit, responsible for customer 360 personalization, building the knowledge graph, and as well as like uh, helping with the M&A integrations, some of the big M&As that we did for Credit Karma and MailChimp. All of that was integrated through my team. And that way we have learned a lot. And those are the learnings I'll be sharing in this session. If you want to connect, feel free to connect with me on LinkedIn, which is my handle in slash Gupta Gautam. All right. So to start with, Intuit has a mission of powering prosperity around the world. And this mission is what our North Star, this is the one that guides us into all of the experiences, all of the capabilities that we build. And for that mission, if you can see when we say around the world, you can actually judge the scale that we are going to operate on, kind of a thing. So to give you an idea about the scale, the platform that we have built, it serves like 10 million small businesses, 58 billion machine learning predictions per day, 93 million consumers. Like it handles 730 million AI-driven customer interactions. I mean, like if in dollar terms, like 270 billion worth of payroll gets processed through us, and 2 trillion worth of invoices are managed on our platform per year. So that's a huge number. And behind all of it is like AI-driven expert platform that we use for serving our customers in small business, self-employed consumers for that. And slowly I'll share with you how we have built it and what are the things while building it to be taken care of. So first question that comes to mind is that what is customer 360? Right. So customer 360 is that, let's say you have a customer, what you know about the customer, right? So two questions become important, that what do we know about our customer and what do our customers need? So this questions is not like typically answered by the customer. We ourselves has to predict whether using AI, whether using our business expertise or like human intelligence or artificial intelligence, what do our customers need? And that is the main objective of personalizing the journey of every customer who comes into our ecosystem. So with these two questions that if we can answer, we can really reach to the conclusion, we can serve them better, and that's how we can power the prosperity and go towards our mission. Now, in this another important part of personalization is that what kind of a data we have to get from the customer, what kind of data we really want to store, what we want to use. So all of that has to be like with consent, has to be with like right legal and also secure way. That's how we have to do that. Now, when we say knowledge graph for customer 360, this is like goes a little bit beyond those two questions. And this is to unlock the relationships, like how do we understand more about our customer? So here, three other questions that come, that what is the financial ownership of this user? And mostly I have worked in the fintech domain. So based on that, this financial ownership where like whether a person owns a credit card or a bank account or like they have some kind of a loan. So all of these things like provide us a overview into the financial ownership of a user. Then comes the identity resolution, which is like whether this is a user, which means like authenticated user in our system, or this is a visitor who is just visiting and like trying out things, but not yet logged in, right? So we need to understand what is their intent. If they are a user or a visitor, do they want to let's say somebody is having a TurboTax, then they want to get more like features from Credit Karma, or like they want to they are running a business, they can become a small business person also, the same person, right? So that identity we have to understand, like what are the intent and what are the offerings that we can provide to this customer. Then comes the customer journey, which is like a another dimension of time where we have to see where is this user in journey with us or in their own life. For example, let's say somebody joined us like 2 years back, and then they are like let's say unemployed, and then after some times they got a job, like and then they after the job they get married, they get like kids, they get like I mean a promotion, so different life events take place, they did some investments. So based on that, we can serve them better by personalization and by personalizing the offerings that we have for them. Because when we talk about any of our products, there are like hundreds of features in each product, right? So these features are very important. Like we don't want to like confuse a customer by showing all the features at once. They should be able to discover those features based on their customer journey, based on their needs, and based on their financial ownership, and based on their intent, like what do they need at this point of time, right? So that is like the objective of that overall knowledge graph that we have to be built to learn more about our customer and their needs. Now here comes the things like that can be served by knowledge graph, which are like graph queries, or it can be analytics, like that can be done, or graph mining. So graph queries are like something which are specifically suited for the graph, right? And then analytics is every company needs it, and the mining is for to figure out things deep insight, and so that we can do better understanding of these insights. A little bit idea about the high level architecture, and this is like I would say 10,000 feet or maybe more from that level. The architecture, it's not as simple, but just for this talk I have tried to simplify it to utmost like level, so that everyone can understand irrespective of their technical background into this architecture. So if you see on the left, users are there who interact with our systems, and when they interact asynchronously, and they like can publish some messages. Publish messages means like they interact with some of our services and offerings, and those offerings provide the messages. Let's say this person ordered this product, this person added this feature, added this user. So those events keep coming. Now we have a stream processor that can listen to that Kafka event bus and process those events, and then it will persist it into the different kind of a stores, right? So because if we have to build a knowledge graph, we need to have a way of storing the data, right? So to store the data, there are different kind of technologies we use. For example, we have a data store for key value, we have a data store for searchable database, and we have a data store for graph data, right? So that all can be stored, and then this is accessible through GraphQL API, which is like a synchronous kind of a way. Using like a REST service, they can access it in a synchronous way, that call an API and get the results, right? And GraphQL, because it is extensible and it is very generic, so that if you want a subset of data, you can access it, and it can, as soon as you add certain things, it's available within few milliseconds for consumption. And these can be called by various users, like our feature management platform, or marketing, or customer success, like sub, right? And personalization, all of these can use it. And then there's another pattern where notifications get published. That is the way we got asynchronous events. Same way we can give asynchronous notification that can be consumed by downstream systems. Similarly, some of the things come from the data lake, which is not coming from the users. These are like the data that gets coming through a batch jobs, and then it gets stored into some Hive tables. And there, if let's say some AI experiment take place, or like a processing take place on the data, all right, those things will provide it, and we can use it to store it in our databases. Now, coming to the second part of this presentation, and which is the real learning that I would say a takeaway from this talk, right? And these are the design patterns that we have developed over time to building the knowledge graph. So knowledge graph, if you see, first part is the data movement. Like to build a graph, you need to have some data coming into the graph. And that data movement, typically people start thinking in terms of pipelines. So the pattern here is that think platform, not pipelines. Because pipelines will be like one-time use only, or it will be like just for some point solution. Whereas platform would be like a generic event processing. You can have multiple stages that can be built in, and you can configure them. For example, you can have standardized implementation for domain, or sessionization, or encryption, decryption, compression, or even schema validation. So all of these stages you can put, and you can use these as per the need for a specific use case. So that way, you don't need to reinvent the wheel every time. Rather, you can just plug and play. And in the platform, you can also have a metadata repository that is for discoverability and lineage tracking. That is it the data which is trustworthy, which is clean data, or do we have consent to use this data? So all of these things come with the platform mindset. And last but not the least, scalable operational platform, which means if you have so many pipelines, it becomes an overhead to maintain all of it. Whereas when you think in terms of platform, there you get the economies of scale. You can have like similar features like auto scaling or monitoring, alerting. You don't need to like keep building it again and again. In platform, you can have it like one time and can keep using it multiple times. The next one is the data storage, which is, let's say, if data is not moving, then the data is at rest, right? So it has to be stored somewhere, and because from that data only you can build the knowledge graph. Right? So here the solution is like polyglot, not monolithic. That pattern really helps us, which means there is no single database technology that can like serve all kinds of usages for the data storage. So we use multiple like kind of a data storage systems. For example, you can use some kind of a NoSQL DB for storing the attributes like key value pairs. And I mean, you can have 6,000 plus attributes in the key value pair, and searchable data where like some of the frequently used fields can be searched, that can be searched using a some kind of a searchable mechanism like Apache Solar or Elasticsearch or any other mechanism that you develop. Then the third is the relational database. So for a knowledge graph, you need to store the relations. And earlier, it used to be by default people going towards some kind of a RDBMS, whereas now the need of the hour is to use some kind of a graph database, which is really optimized for all those multi-hop queries and different kind of storages that we need for the graph database. Then third pattern is on the data access. Like we have consumers which are coming from different purposes. So in that, the pattern is right for me, not one size fits all. So right for me is like synchronous, where you have a request response, like a REST API. Asynchronous, where you publish only the need-based data, and your downstream consumers can subscribe and get it from that. So that's how this pub sub model works, asynchronous, and we have a lot of customers who use asynchronous mode. Like they are not interested in calling the API directly. Then backfill, whenever we have asynchronous, people want like a historical data load. So that also should not be like one time kind of a thing. Rather, it should be repeatable pattern. So we have developed like replay mechanisms by which we can do bootstrap of our data so that new customers can onboard for our knowledge graph. Then another pattern is for the AI tool chain. So AI tool chain is another aspect. Like nowadays, everybody's talking about Gen AI and like LLM, all of that thing. But irrespective of like one model or another model, AI is an integral part of the applications as well as the platform. So in such a case, like a pattern is that it should be deeply integrated, not bolted on, which means like we have to think where should we prepare our feature stores so that people can have a self-serve mechanism to onboard new AI models. They can have like features that can be added or removed, or like use aggregation for those features. Similarly, feedback loop, if models are there, how we can bring the feedback loop from actual model execution all the way to get the 360 view of model performance. So this needs like real-time availability of data to AI models and being able to get the feedback loop so that models can be improved. And then AI pipeline, which means like different stages of AI pipeline should be served from the model, itself from the platform, like data exploration, featureization, training. So all of these things, like if you have to build a AI-powered knowledge graph for the personalization, and that it needs kind of a AI toolchain which should be deeply integrated. And the last pattern that I would like to cover today is that self-serve, not product backlog. So here the mindset is that whenever we have a data, we should not think that it's my data or your data. Data is actually a product in itself. And we have to see that how more and more teams within our ecosystem can use this data, how it is easy for them to use this data to create different features or provide the different products for through UI or through APIs so that consumers can access it, right? So here self-serve so that we don't need to no code, low code, like even there is somebody who has not much technical knowledge, they can also be able to uh, onboard to our system. So we are successful when non-technical business users, they can also discover the data, use our thing, and that way they can onboard to our knowledge graph. So that is like the end goal for this whole platform. So that self-serve is also built into it, right? All right, yeah, that's all from my side. Really nice connecting and sharing with all of you on this. And if you have any questions, feel free to reach out to me, or if you have want to connect to know more, so my LinkedIn handle I already shared with you all.